Hi there, this is Math 7, Unit 5. This is your practice test, or basically your review. We have some special studio guests here with us today, having lunch in my office as we make some videos, so they might be chatting and crunching on chips. We'll see if you can hear them, and if you do, I'm so sorry. We'll tell them to keep their mouth closed as they chew next time. So first of all, it says do not use a calculator in this first part. And this is just a review for what's coming up on your test next week. It says select all the true statements, which means some are true and some are false. So make sure you read every single one of these to see what you come up with. Okay, so we have some various equations, or expressions really. We have a 4.5 and we're subtracting a negative 4.5. Recall that when we subtract a negative number, this becomes simply adding. So is 4.5 plus 4.5 equal to 0? I don't think so. So you'd want to check the box that says false. I don't think so. Just like that. Okay, the next one. We have negative 4.8 plus a negative 3.6. And the thing is, it's saying that it becomes a positive solution. So here I have two negative numbers, right? And when the signs are the same, we find the sum and keep the sign the same. So in this case here, a negative plus a negative should end up being a negative, not a positive. So this would also be a false statement. Okay, so for those of you who are just waiting for me to go check, here's what's going to happen next. For these next few, I'm going to talk through them, but I'm not going to check the boxes. So make sure you're paying attention. Here we go. Negative 1.8, and it says we are subtracting a negative 15/3. Well, we know that subtracting a negative means to add. So we have negative 1.8, and over here we have 15/3, and they're saying that it's positive. Now, I don't know what 15/3 is totally. I'd have to do a little bit of work here. It looks like I could probably reduce that. 15 and 3, I know 3 goes into 15 5 times, so this becomes really negative 1.8 plus a positive 5. And we can see this is a much larger value positive than the negative one is, so positive would be a true statement there. I'm okay with saying it's positive. And the next one, we have 9/4 plus negative 2.25 equals 0. All right, so 9/4, this is going to be a difference between a positive number and a negative number. It says it equals 0, so the question would be, is this actually equal to a positive 2.25? Well, 4 goes into 9 2 times, right? So 4 times 2 is 8. 4 times 2 is 8, right? So then 9 minus 1 is 9 minus 4, 9 minus 8 is 1. So we have 1/4 left over. And so the question is 2 and 1/4 the same numbers as 2.25? Yes, it is. Hopefully you know that 1/4 as a decimal is 2.25. So this becomes 2.25 minus 2.25 being equal to 0, and you can decide if that is true or if that is false. I'm going to probably go with, yeah, that one. Okay, here's the next one. We have 64, and we're going to subtract the negative, which means we're going to add. So a positive plus a positive is a positive. Mostly that is true, unless you're talking about my bank account, which happens to not always be positive. Such a sad day when it happens. Okay, next one, we have negative 1/3 minus 9. I think we're subtracting 9. Or are we multiplying 9? I'm not really sure. This is not really written very well. Because last time when we had to add something, when we added a negative, they put add a negative. This one they did subtract the negative. So I almost want to say this is a multiplication problem. So something you might want to ask your teacher is this a times problem? A multiplication problem? I can't tell. If it is, I'm going to work with that it's a multiplication problem. Then it's a negative times a negative. And whenever we have a negative times a negative, we end up with a positive. So that's going to be just fine. A negative times a negative is a positive, just like a positive times a positive is a positive. But when we mix the signs up, negative times a positive, we end up with a negative. So here we have positive times negative, so far we are negative, and then negative times negative. If the signs are the same there, we should end up with a positive, not a negative. So I would say, no thank you. All right, next one we have, doesn't even work with the answer, we have a negative divided by a positive. Again, when the signs are different like that, we end up with a negative solution. So we'd say nope on that one there. And here we have positive divided by negative. So when the signs are different, we end up with a negative. So that looks good. And then finally our last one, we have 15 plus a negative 8 and a negative 7. Well, negative 8 and negative 7 combine with the same sign to make a negative 15. So really you have 15 plus a minus 15. Does that equal 0? Yes, in most universes it tends to equal 0. And that's it for that first long, crazy question. Again, I didn't check these. Your job is to check them to say whether it's true or false. And I went through them there, so you should be good to go. Number 2. All right. Says let x equal negative 1/4 and y equal 3/4. Yay, here's x and here is y. Which expressions have a negative value? All right, negative value. So if we take a negative number and divide it by a positive number, do we end up with a negative number? Yes, we do. That is going to be negative. So it's yes, it is negative there. If we take a negative 1/4 and we add 3/4 to it, negative 1/4 plus 3/4, does that become a negative number? Well, this is much bigger than that one, so we're going to end up with a positive 2/4, which is a half. It's still positive, so we'd say nope on that one. On this one, we're multiplying a negative times a positive. That is always going to be a negative number. And then finally, we have a negative 1/4 minus, and we're going to subtract a 3/4, okay? So in this case here, we're going to keep going more in the negative direction that way, so that would also be one that is also negative there. So 3 of the 4 are simply going to be negative answers, and 1 is not. Moving on, next page, number 3. Isn't this exciting? I run out of breath sometimes, and then I wish I had a drink of water or something, but then it's just me. Maybe I can have an M&M while I wait. Okay, we're going to take out the M&M. That's right, M&M time, because it is lunchtime. I shall have myself one M&M. There it is. It's green. All right, moving on. Talking my mouth full. Oh, we got text messages. Friend suggestion on Facebook. Yeah, I don't know, person. The number line shows 4 elevations in Death Valley National Park. Find the difference in feet between the elevation at Zabriskie Point and Furnace Creek. So remember, when we're finding the difference, we're subtracting 2 points. So I'm going to take Zabriskie Point, which is right here at 648 feet. So 648 feet. And we're going to subtract Furnace Creek, which is at negative 178. All right. So when I subtract the difference there, it looks like I'm going to add them up, because when I subtract a negative, what do? We add stuff up. This becomes an addition problem. So what I'm going to do right there is I'm going to leave it just like that. I'm going to let you do a little bit of addition work. Go see what you come up with there for your solution, because we talked it through. You should be okay to add that up. I think you can add. Hopefully you're all right there. Moving to number 4. See, I don't do them all. I just do some. Talk through others. That way people kind of get the idea. Oh, they go, oh, it's 7, oh, it's 3. Yeah, come on. All right. Calculate the value of each expression. All right, negative 9 times a negative 3/4. Well, already, a negative times a negative is going to be a positive answer. That's exciting news. Now, to multiply, we're going to go straight across. 9 times 3 is 27, and 1 times 4 is 4. There's nothing I can really reduce here. I can make it into a mixed number if we chose to, instead of an improper fraction. Knowing that 6 times 4 is 24, I could say there's 6 there. And 27 minus 24 gives you 3. So we have 6 and 3/4 as a solution. So either one's going to be fine. Just check with your teacher to see which way they want you to write that. All right, on this next one, we have a negative 9 times 3/4. Same numbers, except now it's a negative times a positive. So we would just simply say it's a negative 27/4, or we could say it's a negative 6 and 3/4. Either one's going to work out just fine. And number 6, select all values that equal negative 5. All right, so 25 divided by negative 5, well, this reduces down to 5/1 because it's a negative. We still have a negative 5, and we're great. This guy right here, negative divided by negative is going to be a positive, so I can already eliminate that one. This one, we have 25 divided by 5, which is 5. It has a negative out in front, and that's okay. And then this one is the same as that one, except we put the negative on top instead of the bottom, so it is also going to be okay. So 3 possible options there for you. Number 7. Solve the equation. Yay, so much fun. So I'm going to multiply over here by the reciprocal, right? And that'll eliminate the 4s, eliminate the 3s, but I do it to this side as well. So be careful here because it's a negative, so don't forget about that. 3 goes into 6 2 times. Negative 2 times 4 is equal to a negative 8. And that's number 7. Number 19, this one's here because it wants to see if you know what to do with a negative b. If you don't like a negative b, here's what we can do first of all. We can add a b here and add a b there and rewrite the problem as 19. Whoops, thank you so much. I did the first one too. Oh no, I did. Sorry about that. Here's this one. Multiply by the reciprocal, 4/3. 4/3, reduce 3 and 6 becomes 2 and 1. Don't forget to multiply -2 times 4, -8. Thank you. See, that's why I have to use the projector and the thing. It's so easy. You just get all caught up in doing math. Okay, so I'm rewriting this just so I don't have a negative b. I'm going to add b to both sides. To rewrite this as 19 equals 14.5 plus b. And that's a little bit nicer. Is it necessary to do that? Absolutely not. But just for those of you who don't like a negative b, there we go. So now I'll subtract -14.5 from both problems. So I have 19.0 minus 14.5. We're going to borrow from here. So 10 minus 5 is 5. Keep your decimal in place. 8 minus 4 is 4. So on this side, I have a positive and a negative. It's going to be a positive 4.5 because that's a bigger absolute value, equals b, and that's what we got. And number 9, we're going to divide both sides by 30 in order to get rid of the 30 over here. So d equals -0.3 divided by 30. Now that is really funny looking, right? You might think to yourself, yeah, I don't know about that. So I know you hate fractions. Totally get it. I love fractions though. So this number as a fraction is 3/10. It's -3/10. And I'm dividing that by 30, right? So dividing by 30 is the same as multiplying by the reciprocal. So, all right, sorry about that. I had to take a quick little break. So again, we were saying that if you take the 3/10 and write it as a fraction, and then you divide by 30, then when you turn this to multiply by the reciprocal, watch what happens. This becomes multiply by 1/30. And now I can reduce 1. 3 goes in here 1 time, and 3 goes in here 10 times. So now when I multiply straight across, I have 1 times 1 is 1. 10 times 10 is 100, and it's a negative times a positive, so I have -1/100. Okay? So there's a lot nicer answer in that regards there. So don't be afraid of fractions. They can be your friends. Okay. All right, down below we have this chart here, and we see that we have a table of transactions from different bank accounts. We're going to fill in the missing numbers. So we have an old account balance is this. There's a transaction of -28, and the new balance is 214. So we can see what's happening here is that in this regard here, we're losing or taking out $28, and the new balance becomes that. All right. So in this one, they start with $86, and let's say you have $86 in your account, and you buy something for $120. How much money do you have left in your account? Now, really, you have no money, but now you owe the bank some money. So for this one, we can find the difference and say 120 minus 86. We borrow there. 10 minus 6 is 5, and 11 minus 8 is 3. So my new balance is $35, but again, because I had 86 positive and I subtracted -120, my balance is now in the hole. I have a debt now of $35. For number 11, we see we have 132, and my new balance becomes a positive 435, which means I'm going to have a positive transaction here to go from $100 to $400. And in estimating, really you could say to go from 100 to 400 is 300, right? To go from 3 to 3 is 0. To go from 2 to 5 is going to be 3. 303. Let's see if that's right, because if I find the difference between these two numbers, I should get 303. Subtract the difference, 303. Yep, and we're good there. All right, number 12, we can see the new balance is 24, and they put into the account $68. But before, there was some other balance here. Now, to add 68 and only have 24 means that the old account balance must have been a negative amount. Must have been a negative amount. So we're going to find the difference between these two and make it a negative amount to find out what the balance was going to be. So 8 minus 4 is 4, 6 minus 2 is 4. So negative 44 plus 68 becomes 24. And again, if you're not quite sure on that, you could look on a calculator. If I do 44 and make that a negative, let's clear. Let's go negative. Whoops, clear. 44. Where's my button at? Well, we'll do it here. Let's do 68. We'll do this. Let's do 24. Go the other way. 24 minus 68. 24 minus 68 Get you a negative 44 as an answer there. Okay? And then finally, this last one, negative 20, negative 35, and negative 55. It says, explain what each of the numbers, boom, 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 tell you about his account. Okay, so negative 20, this tells us that he already was overdrawn, all right? He had negative $20 in his account. He already owed $20. Maybe he bought something for $35, so his account amount went down even more. And now he's down below zero at negative 55, meaning he owes his account $55 to make it come up to being balanced. All right, number 14. What numbers are located exactly 5/3 of a unit from P on the number line? So the way this one's going to work, we're looking at thirds, and we can see already that the whole thing has been sectioned into thirds. Yes, you have your whole numbers here at 1 and 0 and 1 and 2 and 2. But we can see that between each of these whole numbers are thirds, 1/3, 2/3, 1/3, 2/3. So we're going to move 5 units away from P in both directions. So we'll go 1, 2, 3, 4, 5, and that's going to be one value, which is going to be 1. And we'll go the other way, 1, 2, 3, 4, 5, which is right here, and we're going to say negative 7/3. So those are both 5/3 units away from where we started at P. Number 15, select which expression is equivalent to 35 minus 42. Okay, so again, when we subtract the negative, that's the same as adding. So do we see 35 plus 42 anywhere? We sure do. It's right there. All right, and the other ones are just not going to be the same. All right, 16. What's the value of negative 2 times 12 times 14, 1/4, sorry. First of all, you want to reduce this. 4 goes in here 1 time, and 4 goes into 12 3 times. So now if I rewrite this, I have negative 2 times a 3 times a 1. Negative 2 times 3 is negative 6. Negative 6 times 1 is negative 6. 17. If a bank represents deposit with positive numbers and withdrawals with negative numbers, what could 5 times 25 represent? So this is 5 groups of 25. 5 groups of 25. Now notice it's positive. So we know it's a positive deposit. So we would probably say this is going to be a deposit of $25 happening 5 different times. So we can see here we have 5 withdrawals. We have no negative numbers, so that doesn't make sense. A $5 withdrawal followed by a $25 deposit doesn't make sense. And a $5 deposit followed by a $25 withdrawal. Again, with the withdrawal, it just messes the whole thing up. So we're left with just 5 deposits of $25. Makes the most sense. Number 18, what's the value of this? We have a positive number, and then we have 2 negatives. So we can group those together first of all, 0.85 and 0.45. Add up the sums, so we have 13. So we have a negative 130. So now let's find the difference between 17.5 and 130. 0 minus 0 is 0, 5 minus 3 is 2, decimal, 17 minus 1 is 6, and 16. And the positive is larger than the negative, so we're going to keep it as a positive 1620 right there. Okay, and the last one here on your review, zoom in real quick a little bit. It's a bonus one here. It's a good question. It says Penny walks up to a tank of water that can hold 12 gallons. Okay, so we have a tank of water. Let's just sketch a little tank here of water. And we're going to make a tank like so. And we know that it can hold 12 gallons. All right. When it is active, a drain empties water from the tank at a constant rate. So there's some sort of drain here that will let the water flow out at a constant rate at the bottom. When Penny first sees a tank, it contains 8 gallons of water. All right, so if this is 12, then we could say somewhere right here it's about 6. Okay, and we could say 8 is about here, and 10. Again, we could just make up some numbers here, 4, 2, 0, not a big deal. So when she first sees it, the water level is right here at about 8. 4 minutes later, the tank contains 5 gallons of water. So here's 5. Alright, so we know that it decreased that much from 8 to 5 gallons and did that in 4 minutes. So that's just kind of information that we have so far. Okay, so we have a water tank here. It's at 8 gallons, and in 4 minutes it goes down from 8 to 5. Now, how much of a decrease is that, first of all? All right, we're starting at 8 gallons, we go to 5, so the difference there becomes 3. So we went we lost 3 gallons, negative 3 gallons in 4 minutes is what we have. All right, so I'm not looking at the question quite yet, just looking at what do we know so far. So the question then does say, A, at what rate is the amount of water in the tank changing? Okay, use a signed number and include a unit of measurement in your answer. So we want a signed number, that means positive or negative, and we want a unit of measurement, so what that's going to be. So think of it this way, all right? If I knew that I was talking about how many gallons of water per minute that I was talking about here, gallons per minute, all right? We could say gallons, and we could put minutes right here, okay? And we knew that we lost 3 gallons. Well, let's do it the other way, because in terms of which one's happening first, or the more independent variable, what doesn't change is going to be, the constant is going to be time. So let's put minutes here, and let's do gallons here. Make a quick little t-chart here to say that we lost 3 gallons in 4 minutes. Okay, minus 3 gallons in 4 minutes. So as a rate, we would do a y over x, which means we're losing 3 gallons every 4 minutes. Now, of a unit rate, its y over x is negative 3 over 4, which means my actual rate would be we're losing 3 gallons, or I could say I'm using 3/4 of a gallon per minute. And the reason we say 3/4 is if I multiply this by, or negative 3/4, I end up with negative 3. So in 1 minute, I would lose the same rate, negative 3/4, I would lose negative 3/4 of a gallon. So every 1 minute, we are losing negative 3/4 of a gallon. That becomes my rate. That's my y over x. Okay, so that's what we have so far. We knew that we lost 3 in 4 minutes, which as a rate becomes 3/4 of a gallon per minute. The next question then says, how many more minutes will it take for the tank to drain completely? Okay, we know we're losing 3/4 of a gallon every minute, and look at where we are now. We're at 5, which means we have to get down to 5. So I can think of it this way, all right? I can think of, I want to know how many 3/4 is it going to take until I get down to losing 5. So if I put this as an x variable, put the x there for in terms of my time, I want to know how many minutes at that rate it will take to get rid of the remaining 5 gallons. Okay, I want to drain it completely. So how much time is it going to take for us to get there? Okay, because again, back to over here, this is my y, this is my x. So y equals my rate, negative 3/4 times x. So that's all we're doing here. We're saying I want to know about how about to get rid of 5 gallons. How long is that going to take? So to find the x by itself, I'm going to multiply both sides by a 4/3, and those cancel out, of course. Multiply this by 4/3, and I end up with 20 over 3. Okay, because I'm just talking about how many more minutes, I'm not going to worry about the negative number. Okay, because time's not going to be negative, so I'm just looking at the rate. And so I know it's going to take me 20/3 of a minute. Well, how long is that? Well, 3 goes into 20 6 times. 6 times 3 is 18, and then 20 minus 18 gives you leftover 2. So 6 2/3 minutes is how long it would take to drain out the remaining 5 gallons of water. Now the same thing can be done with part C. How many minutes before Penny arrived was the water tank completely full? Well, how much are we talking about filling up here? Well, 8 to 12 is a difference of 4 gallons. So once again, we'll do 3/4 x equals 4 gallons. We multiply by the reciprocal, and we end up with x equals 16 over 3. 3 goes into 16, 5 times, 3 times 5 is 15, 1 left over, so 5 1/3. So it would take 5 1/3 minutes is how long it would have taken to be at the point there. So you end up with fraction answers, which seems a little weird, but that's just kind of what I worked out there. Again, it's a bonus one, so it's just something to think about, but good to draw a little picture and think about, you know, how much gallons are we talking about here. The important part was finding that rate, like what's that decrease? What was that going to be, you know, to go from one to the other? So we're talking about going from 3 to, 3 gallons, losing 3 gallons every 4 minutes, and recognizing that that becomes a -3/4 of a gallon per minute. That is our rate. That's our y over x. So that's really it. And this part here came from back in, I think that was Unit 2 that popped up first of all. So having you apply that to here and then multiply with fractions and solve equations, which kind of comes from today's, this unit. All right, that's it. Have a great day, and we will see you next time.